Hello all. Today I am going to discuss linear programming problem, minimize a function using the graphical method. As already I have discussed one problem, but that is based on the maximization function. Now this particular problem is based on the minimization. So minimize z is equals to 20x1 plus 40x2 subject to the constraints, and all the constraints here are greater than or equal to. That means the feasible region will be above the lines. If it is less than, then the feasible region will be below the lines. So let us solve this particular problem. So given minimization function, so minimize z is equals to 20x1 plus 40x2 subject to constraints 36x1 plus 6x2 greater than or equal to 108, 3x1 plus 12x2 greater than or equal to 36, 20x1 plus 10x2 greater than or equal to 100, where x1 x2 will be greater than or equal to 0. Now here if we observe the constraints, there is a scope for simplifying. So we can simplify the constraints. Suppose the first constraint can be divided by 6, and second constraint can be divided by 3, and third constraint can be divided by 10. So this becomes 36x1 by 6 plus 6 by 6x2 x2 plus greater than or equal to 108 by 6. So we'll get 6x1 plus x2 greater than or equal to 18. So simplified first constraint. Second constraint, we have 3x1 divided by 3 plus 12x2 divided by 3, which is greater than or equal to 36 by 3. So we'll get x1 plus 4x2 greater than or equal to 12, which is considered as a second constraint. Third constraint, we have 20x1 divided by 10 plus 10x2 divided by 10 greater than or equal to 100 divided by 10, which can be 10 into 2, so 2x1 plus x2 greater than or equal to 10. So now we have simplified the given constraints into this format so that calculations becomes easier and very easily we can find out the values. So this I am considering as 1 and 2 and 3. Now we have to find out the corner points, as we have 3 constraints, so by taking 1 and 3 and 2 and 3, so in the first one and this one in the second one. In the first one we will be taking 1 and 3, and in the second one we will be taking 2 and 3. Now here, so we have the constraints 1 and 2. So the first one is 6x1 plus x2, which is equals to 18, and second constraint we have x1 plus 4x2, which is equals to 12, and third constraint we have 2x1 plus x2 is equals to 10. So now we have converted into equalities. We have converted this into equalities. Now I am considering this one as 1, 2 and 3. As I told you, by solving 1 and 3. So corner points for 1 and 2 by solving. So the first one is 6x1 plus x2 is equals to 18. Third one is 2x1 plus x2 is equals to 10. Now to solve these two equations, if we subtract, then there is a possibility to find out a particular value. So this becomes minus, this becomes minus, this becomes minus. So 6 minus 2 will be 4x1, and this gets cancels. 4x1 is 18 minus 10 is 8. So x1 will be 8 by 4, that is equals to 2. So x1 will be 2. We got one value. So substituting this, as we have taken 1 and 2, and we are substituting this x1 in 3, where we get the value very easily. So third one is 2x1 plus x2, which is equal to 10. So 2 into 2 plus x2 is equals to 10. x2 is equals to 10 minus 4, x2 is equals to 6. Now we got two coordinates, that is x1 is 2 and x2 is 6. x1 is 2 and x2 is 6. In the same way, we have to calculate, or we have to find the other coordinate for the another constraint using second and third. Now we have calculated 1, 1 and 3. So we got the coordinates here. x1 as 2 and x2 as 6. Now what we will be doing? We will be calculating corner point for 2 and 3. So second equation, that is x1 plus 4x2 is equals to 12. So third equation, we have 2x1 plus x2 is equals to 10. This is second and this is the third. Now by solving, So here very easily we can find out the x2 value. So by solving third equation, x2 will be 10 minus 2x1. So we got the directly by simplifying or by solving the third equation, we got the x2 value. So x2 value is now 10 minus 2x1. So if we substitute this in second equation, so substitute in second equation, that is the x2 value. So we have x1 plus 4x2 is equals to 12. So x1 plus 4 into 10 minus 2x1 is equals to 12. So x1 plus 10 into 4, 40, 4 into 2 minus 8x1 is equals to, so 8x1 minus x1 minus 8x1, so plus x1 minus 8x1 is minus 7x1 is equals to, so 12 minus 40 will be minus 28, this gets cancels, and 7 fours, so x1 will be 4. So substituting, as already we got here x2 value, we got here this one. So we need to find out this x1, we got the value 4. Substitute in x2. So x2, what do we have? 10 minus 2 x1, which is already here we have simplified. So now what you have to do, whatever the x1 value we got here, that is 4, we are substituting that in the x2. So 10 minus 2x1, that is equals to 10 minus 2 into 4. So 10 minus 8. 10 minus 8 will be x2 is equals to 2. So now here we got one more coordinate, that is the x1 is 4 and x2 is 2. Now manually, as already in the previous video I have discussed graphically how you can identify the intersection point. So manually also I have discussed in that. So by taking the first and second constraints 1 and 2, we'll see the intersection points. Where do we get the intersection point? So axis intersection. So the first equation is the 6x1 plus x2 is equals to 18. So here when x2 is equals to 0, that means 6x1 plus 0 is equals to 18. So 6x1 is equals to 18. So that will be x1 is equals to 3. That means here we are getting a point. What is that? When x2 is equals to 0. That means x1 is 3, x2 is 0. Now, when x1 is 0, so here we have seen when x2 is 0. Now we will see when x1 is 0. When x1 is 0. So 6 into 0 plus x2, that is equals to 18. So directly we got the point x2 is equals to 18. So when x1 is 0, x2 is 18. We got one more point. In the same way, we will be doing for the 1 and 2. So first constraint we have done, and second constraint we need to, so here we have done for the first constraint when by taking when x1 and x2 as zeros. Second constraint we have x1 plus 4x2 is equals to 12. So here also when x2 is considered as 0, so x1 plus 4 into 0 is equals to 12. So x1 is equals to 12. So here we got one more point, x1 is 12 and x2 is 0. One more coordinate we can identify. Now we have taken x2 as 0. Now when x1 is 0, so x1 is 0 plus 4 into 4x2 is equals to 0. 4x2 is equals to 12. x2 is equals to 3. So here we got one point when x1 is 0. So the first one, x1 is 0, x2 is 3. So we got the point. In the same way, third constraint, that is 2x1 plus x2 is equals to 10. So here also when, because here very easily we can find out one particular value. So when x2 is 0, so 2x1 is equals to 10, x1 is equals to 5. So here we got one coordinate when x1 is 5, x2 is 0. In the same way, when x1 is considered as 0, so 2 into 0 plus x2 is equals to 10. So x2 is equals to 10. Directly we got the value. So x1 is 0 and x2 is 10. See, we got how many coordinates? Let us observe. Here, corner points, to identify the corner points, to evaluate the corner points. See, we have so coordinates. First, here we got 2, 6, and here we got 4, 2, and here we got 3, 0, 0, 18, 12, 0, 0, 3, 5, 0, 0, 10. That means if we plot all these coordinates on the graph, one or the other way, one or the other point it will be intersected. So here the minimum while evaluating, so intersection point, here we have to find the intersection point. So we have to evaluate all these coordinates 12, 0, 0, 0, 0, 10. Okay, so let us see the evaluation now. So two values for evaluation. So minimize, function is minimize z is equals to 20x1 plus 40x2. Suppose I am taking the coordinate 2, 6. So x1 and x2. So 20, 2 plus 40 into 6. So we'll get one value. Let us see. How much we will get? So 20 into 2, 40 plus 6 will be into 6, 240. So 240, 40. So will be 280. Now see here coordinates for the we can take all the coordinates and we can evaluate. I am taking the basic coordinates. If you draw on the graph, you will come to know all the corner points. But manually when you are doing, you can test all the coordinates what you have calculated. So 4, 2 another coordinate. So 2 into 4 plus 40 into 2. So 80 plus 80, that will be 160. So 12, 0, 20 into 12 plus 40 into 0. So 20 into 12 is 240. So that will be 240. And 0, 18. So 20 into 0 plus 40 into 18. So it will be 720. So here as the minimization it is the minimization function. So from these values, from these z values, whichever is the minimum, that we will be considering. So the minimum in this values is the 160. So hence minimization of z is how much? 160. And this 160 in which coordinates? It is at 4, 2. That is x1 is 4 and x2 is 2. So points at 4, 2, that is when x1 is equals to 4 and x2 is equals to 2. So 2 into 20 into 4 plus 40 into 2. So how much you will get? 160. So which is matched. So this is how we solve the linear programming problem, and graphically we can, if we plot all the coordinates, we will get the feasible region above the lines, because here this is a minimization function, and all the constraints are greater than or equal to. So the feasible region you have to identify which exists above the lines. So and you will get the corner points. So those corner points, if we evaluate, we will get the minimization value. Thank you.